The Park Plus model was developed to take advantage of existing data that cities and campuses already have in place to define parking demand relationships based on the interplay between land use and parking. The first piece of data needed to evaluate parking demands in Park Plus is a community's land use information, typically provided in parcel format. Here, you can see that this particular model uses parcel information provided by the city's planning department. Most of the data provided in this table is not necessary for the evaluation of parking demands, but we maintain the integrity of the data to ensure easy transition from community data to Park Plus analysis, primarily for future updates. There are only a handful of fields in the land use data that are necessary for evaluation, including type of land use and the intensity of the land use. The parking information used in the model includes type of parking, prices of parking, user restrictions, and parking occupancy. Once the data is in place, the user can access the Park Plus model interface, which provides several input, analysis, and output features. The first step in calibrating the model is to define your calibration scenario by pressing New and giving your data a name. After naming our calibration scenario, we can begin to develop specific input characteristics, including a preferred analysis time and period. In this example, we will use weekday conditions and set our analysis time to the peak hour. Second, we will define multimodal characteristics for our various user types. Multimodal data can come from specific community data, transportation studies, local knowledge, or U.S. Census information. Third, we will set the effective capacity of the model, representing when a facility is considered full for modeling purposes. Fourth, we will begin to define private parking relationships within the model. These relationships define how parking is allocated between user and development and create a more realistic modeling environment. After completion, there could be hundreds of specific parking relationships defined by the user. Finally, we will define walking tolerances, which is the last step in calibrating the model, defined as a baseline within the interface. Walking tolerances are variable and can be set by the user or defined on scenario-specific basis. The output of the model is for the entire study area and provides several pieces of summary information, including parking demands, overall surplus or deficit, demand that can't be met, and the demand calculation based on more traditional methods. The model can also drill down on specific areas to understand parking demand outputs at a block, node, or development level. You can also change the time of day to view parking demand results for various times of day, which help to understand demand balancing during different peaking conditions. Finally, the model output provides specific parking generation rates for each individual land use in the study area. In this example, we can see that the generation characteristics for apartment uses vary by location, depending on the actual parking conditions at each site.